look at it. So congratulations on making it through this section of the course, and I'll see you over in the next one.
Welcome everyone. In this section of the course, we're going to be talking about laptops. So the internals of a laptop, or the components that are inside of it, are actually very similar in general to the actual components that are inside of a desktop computer. And what I mean by that is that we'll have a CPU, we'll have RAM, a motherboard, all of those components that we are used to seeing in a desktop computer. Well, those are packed inside of a laptop as well. They're just in a much different form factor. Of course, they need to be a lot smaller to all fit inside of a laptop. And then another core consideration or difference for laptops is that, of course, they have the majority of their peripherals already attached to them, like the screen, the keyboard, and the mouse. So what we'll be doing in this lesson is I've actually got a laptop that we're going to be using to take a look at, and we'll talk more about it actually in this video here. But what we'll be doing is we'll be opening up this laptop, so I'll show how to open it up, and we'll be taking a look at some of the components, identifying them in the laptop, and we'll talk about what ones are easily repaired or are feasible to actually be replaced by a standard help desk technician without the use of special tools or equipment. And we'll also talk about some of the ones that you would maybe want to send away back to the manufacturer or repair shop to actually have them repaired or replaced. So with that being said, let's hop over now to the workbench and take a look at this laptop and talk about where I got it. So this is the laptop that we're going to be using in this section of the course to take a look at some of the internal components for it. And it's a Dell laptop. So if I just flip it over here, it is a Dell Latitude 5480. And one of the reasons I picked this laptop is because this is a very, very common business laptop. And nowadays you come across either something similar to this, or the Lenovo ThinkPads are another very common one. And then their form factor and functionality are going to be pretty similar to this laptop. So this is another off-lease laptop that was probably part of an IT department somewhere, and I picked this up off-lease refurbished for $200 US. So definitely an affordable way to get actually a half-decent laptop these days. With that being said, there is, of course, zero requirement for you to go out and purchase this laptop or any laptop for this section of the course or for this course. And I'm also going to be showing some tools that I'll be using to open this up. And of course, there's no requirement to purchase any of that. If you're working at a help desk, then they should be providing the tools that you need anyway to repair any part of computer or really anything. So with that being said, I'll wrap up this lesson of the course, and I'll see you over in the next one where we take a look at opening up this laptop. Welcome everyone. In this lesson, we're actually going to be taking a look at how we can open up the laptop computer that we're going to be looking at, and we'll talk about some of the tools that I'm going to be using to actually open it up. So let's hop over to the workbench now, take a look at opening up this laptop. Before we actually go ahead and start taking apart the computer, I just wanted to quickly go over some of the tools that I'm going to be using. So again, just a quick call out in that you don't need to go out and buy anything for this course, including this kit. This is one of the ones that I use on a frequent basis that I purchased for myself, and it actually contains the majority of tools that I'll use when I'm opening up electronics. So I'll just go over, it's an iFixit repair kit, and I'll just go over quickly the contents of it and some of the items that I use on a day-to-day basis. So the very first one that I'll call out is the screwdriver. And of course, you've already seen me using the screwdriver. Doesn't need too much explanation. It takes bits in the top here, which is kind of nice. So you can just swap out the bits. And then it comes with a handful of different bits here. And I'll just call out some of the core ones that you'll see on laptop computers or even some mobile devices. So the first one is this one right here, which is the Phillips bits. So actually along this whole row are Phillips bits. And they come in different sizes that are numbered. And the bigger the number, the bigger the bit. So this is a number 2, which is probably the one that you'll see the most common on the outside of desktop computers that I was using in the last lesson. And we've got a number 1 here, a 0, 0, 0, and then 0, 0, 0. And yeah, so you've probably seen these a bunch of times. These are just like the star-shaped bits. The next most common one that I'll see in mobile devices or in laptop computers, and it's becoming more common, is this style right here. So I'll just take one out. So I'll just try and get it in focus for the camera here. So this is called a torque style, or TRX. And it's kind of hard to see, but it's essentially like a Phillips, but it has some extra spines on the star of it. And I commonly see these on laptops. And this one's also got like sometimes they'll call it a security style where they'll put something poking up from the middle of the screw, and this one has a hole in it so that you can work on those. And you'll see this abbreviated generally, and I'll see if we can actually pick it up on the camera here as a TR, and then the size. So that one we were just looking at there, that was a TR10 size one. So those are the most common bits that I see. And then I'll just show a couple of the other tools that we've got here. So this tool right here, this is like a metal spudger tool. So this is used for actually opening up the laptop, and I'll show it how we actually use these when we are opening up the laptop. Essentially, this is just for prying and opening pressure fit electronics. And I'll use it to pop this one out. You've seen me using this as well, just as a pointer, but this is also another spudger tool. So these are called spudger, and essentially we just use these for prying open pressure fit electronics, and I'll show how to do that. And this one's nice in that it's all plastic, so we don't have to worry about shorting anything out when we're actually working on the computer or any electrostatic discharge or anything. Okay, it comes with a suction cup also, which can sometimes be handy for opening up mobile devices, or if we're doing a screen repair or something. Then comes with these plastic shims, which you'll sometimes need for opening up the computer cases or mobile cases, and I'll show how we use those. We also get a set of ESD tweezers, and then this is just another spudger tool as well here in a different shape. So what I'm going to do is I'll actually take out this spudger because we're going to need it, and I'll grab a few of these shims here. You just pop out a handful of them, and we're going to need the screwdriver, and I believe we'll need the Phillips 0 size bit. Okay, so I brought the laptop back over here, and what I'll do is I'll just flip it over and we can see how they're held together. So pretty much on all laptops, you're going to see there's a bottom panel that comes off, and it's just held in place with screws. So I'll just hold this up close to the camera so you can see. This one's just using Phillips screws, and they're all around the outside, so it's pretty easy to take this off. First thing I'll do is I'm just going to go around and loosen off all of these Phillips screws. So one thing you'll commonly see actually in these laptops, and I'll just show it quickly on this one, is that they'll use retaining screws. And what that means is that even when the screw is all the way loose, there's like a little lip on it that holds it in place. And that's kind of nice because it means that we can't actually lose these screws. They stay in place. So just something to keep in mind, like if you keep screwing this forever, it's never going to come out, but it's all the way loose. So I'll just do the rest of them now. Okay, I've got them all loose, but you see actually the back of this case that actually doesn't lift off yet. That's because it's using what's called a pressure fit, and a lot of modern electronics these days, phones, laptops, routers, all your IoT devices, they use something similar to this where the screws, hold it in place, but it's also been clipped together to keep it nice and snug and keep the dust out. And so we need to use a tool like this spudger, or sometimes an even more heavy duty one like the metal one, to open it up. What you'll generally see on these devices, if I just show here, is that there is going to be somewhere that we can get our device in to start opening it up. And on this one, if we can just take a look, it is right here. There's just this tiny, tiny little hole here. I'll see if I can get the light on it so it's in focus. We've got this tiny little hole here that we can actually just fit our tool in and start working that way. So that's what I'm going to do right now is I'll just start gently prying it open. Got the tool in here, and then this is where these shims can come in handy, is now we can actually put a shim in here so that it's not going to close, and then I can try and start working my way across here. So I'll just put that shim in. That actually makes it easier. And so what I'm doing actually, just to show you, is I'm just inserting this device in, and I'm just kind of gently walking it back and forth. I'm not like really prying on it, just gently as I'm walking back and forth here, and it's actually loosening this up. So I can get the shim out of here now. Sometimes you'll need to leave these in, but this one, once they've been opened up a few times, they're not as stiff. If it's the very first time opening it up, then they can be a little bit stiff. And once you get to a point like this, it's actually really tempting to just try and, pull this off. What I've actually done and seen happen is if you do this, you can snap it at the next point. So it would like snap here. So I would still recommend just apply gentle pressure with your finger and still get the spudger in there. Put it as close as you can to those clips and just walk your way around. And make sure that you are just gently prying it so that you're not breaking any of the clips or the internals. And again, I'm just going to really gently walk my way along here. One last one here. Perfect. And I've got it off. So I'll just set this down here. And now you can kind of see how these captive screws work, and that, they're held in place. So if I wobble them, they won't fall out. So I'll just set this to the side, and we've got the laptop here. So now we have access to the majority of the internals. And what I'm going to show, just for the completeness of this video, is I'll now show how to put this back on. And then when you see me in the next video, so I'll have it open and we'll take a look at the internals of this laptop. So let's take a look at how to put it back on. Again, we're just going to line it up, making sure our orientation is right. And once we got it on, it's pretty much as easy as just pushing these down until you hear them, and they'll just kind of click in place. It does sound a little bit like it's breaking when you're doing this, but as long as you've got it all lined up, it doesn't take a lot of force just to clip them back in place. And now it's as easy as just going around and putting the screws in. So I'll do that. And I'm just going to be careful. They doesn't take a lot to tighten these down. Like once they're as tight as you can kind of go with reasonable force with your hand, that's good enough. You don't want to over tighten any of this stuff. Perfect. I've got them all back in here and it's back firm, and we're all done taking the lid off this and then putting it back on. So that wraps up this lesson. I'll see you over in the next one where we take a look at the RAM. Welcome everyone. In this lesson, we'll take a look at replacing the battery for the laptop. And this battery is the one that actually is what powers it on or keeps it powered on if we have it unplugged from the wall. So let's hop over to the workbench and take a look at how we could either replace, remove, or install one of those. Now that we've got the laptop opened up, we can actually start taking a look at working on the inside of it. And this laptop, of course, it doesn't have a case like the other one that's metallic. It's actually a plastic case, so I don't have anything to ground myself on. So what I'm actually going to do is I have that grounding strap still. I have my wrist strap here, but I'm not going to use this because it's a little bit hard to film with, and I find it sometimes gets in the way. And personally, myself, I think they're a little overkill to need them when you're working on a computer like this, especially when I have an anti-static mat and you ground yourself first. So what I'm going to do is I'll actually just got this cable here, and this is of course plugged into the ground, so it's a good ground. And I'm just going to ground myself on this. And for myself, I think this is sufficient grounding to then work, especially since we've got the anti-static mat here. So if you're working, somewhere, they may have specific rules that you need to follow or precautions. And of course, I'd recommend following those rules. But, for myself, that's my comfort level. And to date, I have never, ever shocked the computer by just following that one simple rule of grounding myself before touching it. So another safety thing or thing that we should take a look at before we actually work on the internals of a laptop is kind of similar to on the desktop computer where we would unplug the power supply, is we should disconnect the battery. So what we're actually going to take a look at very first in this laptop is the battery, which is down here in the bottom right-hand corner. And I'll just zoom in on a little bit to make it easier to see. Perfect. So here we've got the battery. And what I'll do is I'll just show how to take it out of this computer. And this is one of those things where it's going to differ a little bit by manufacturer, the battery and the cable they use. Some of the other components like the RAM or the drives or things like that, they're going to be standard and use standard connectors. But the battery and the battery connectors, they may differ between manufacturers. So this one, it actually just has one screw here. It's right here. It does have some other screw holes here, but it actually has a symbol not to screw them in. So they aren't screwed in. So what I'll do is I'll just take out this one screw here. It's just a standard Phillips screw. Loosen it up. And this is another retained screw, so it doesn't come all the way out. And then over here, we've got the actual connector for the battery. If you can see, this is where the cable runs from the actual battery. And it has this almost like little piece of fabric here you can fit your finger in or a tool in to lift out, and it just pulls out. So just pull it out, pretty much straightforward as that. And we'll lift it up so we can actually just take a look at this battery. So the first thing I'll call out here is we've got this 42 watt hours. So this is just a measurement of the capacity of this battery. The bigger this number is, the bigger the capacity of the battery, and then the longer the computer could run off of it. So one thing you can do is sometimes you can get bigger batteries that will still fit in this computer. So I've actually seen bigger ones for even this form factor of computer, and you could put a bigger battery in to actually extend the life of it. And one thing too is obviously with these batteries, like if you ever experience this with your phone battery, as you charge and discharge them, they won't charge up to that same capacity. And over time, they'll get to the point where they can't hold much of a charge, and you'll need to replace them. So definitely something that you could take a look at replacing or upgrading in a laptop computer, and that's a pretty standard thing for to do without actually needing to send it back to the manufacturer. So for the rest of the videos of this course, I'll actually have this disconnected from the laptop just for that safety requirement, and I'll encourage you to. But for completeness of this video, I am just going to show how to install it back in. So you'll see on the bottom here, there are these two tabs right here. There's one in here. Kind of hard to see me if I hold my hand over. Makes it a little bit easier to see. But these actually just have to like slot in on an angle. Again, this is going to be different for every battery, but that's just how this one works. And then it just fits in. Doesn't even clip or anything. It just kind of fits snugly in there. And we just got this one screw that holds it in place. And then this clip just clips right back in. Doesn't need much pressure, just a gentle, I can feel it clipped in. Perfect. And now we've got this back in. And that's going to wrap up this lesson here. I'll see you over in the next one. Welcome, everyone. In this lesson, we'll take a look at how you can replace the RAM inside of the laptop. So let's hop over to the workbench now and take a look at how to do that. Okay, so I'll just actually start here by grounding myself. With that out of the way, now we can take a look at the RAM in this laptop. So the RAM is located here, and what I'll do is just zoom in so we can see how that connects a little bit more. Perfect. So the RAM is fairly similar in a laptop computer to a desktop computer. It's still in that DIMM format, so dual inline memory module. It's just in a different package. It's in the SO-DIMM, so it stands for small outline DIMM. And it actually comes in and out fairly similar to how it would come in and out in a desktop computer. So we've just got these two metal clips here. There's one on each side, these little metal clips. And I'll just zoom in even further so it's a little bit easier to see those here. So I'll just show the one on this side. We've got these metal clips, and this is fairly standard in laptops. And to release this, if I just zoom back out here, you just push down on those. You can do it with a finger or your tools or something, but you just kind of push and pull out, and then it lifts up, and then you can just gently lift it out. And I'm still doing so, holding the edges. And you'll see there's quite a few similarities between this and the desktop RAM, and then of course we've got all these contacts down here in the bottom, and we've actually even got this standard kind of little indent here that helps us so we don't put the wrong format of RAM in. And if we just flip this over to take a look, so the RAM in here, this is actually 16 gigabyte card here, and it is that PC4, so this is DDR4 RAM, so the more modern kind. And again, so this clip would then line up with that DDR form factor. It's actually pretty straightforward to install this as well. So of course we've got to have the orientation right. Like if I go to put it back in like this, you'll see it actually doesn't line up. So I'll flip it back over to get that right orientation. And then it kind of goes in almost on an angle. So I'm putting this in on maybe like about a little less than a 45-degree angle. So you see I have it like lifted up like that. And then we just push it down and the clips will hold it in place, and it's seated back in place. You can actually see if we just look over here beside it, we actually have another slot here for RAM, and it actually gives us a heads up, this is the DIMM slot and it's DDR4. So this would be a nice upgrade that we could actually perform on this computer as long as we double check the manual and made sure that it would actually be able to accept more RAM, which my guess is it can probably do up to 32 gigs or 64 gigs. Then we could easily slot in some more RAM. And replacing the RAM or reseating it or even upgrading the RAM is something that obviously we can do without many standard tools, and is well within the realm of something that an end user or the help desk, an internal help desk, would be able to perform. That wraps up this lesson. I'll see you over in the next one. Welcome, everyone. In this lesson, we'll take a look at how to actually install, replace, or remove the drives inside of this laptop. So let's hop over to the workbench now and take a look at how to do that. Okay, so I'll start again by grounding myself here quickly, and then we'll take a look at the drives inside of this computer. So this computer can actually accept two different formats of drives, and the drive bays, or the area where they're stored, is actually down here in the bottom left corner of the computer. So I'll zoom in so we can get a better look at that. So just zoomed in, this is the section here where we could put the drives, and we actually have two different form factors of drives that are accepted in this computer. So the first one is that 2.5-inch, either SSD or HDD. You can actually see it just says HDD right here. And so I've just got that form factor right here. So we could actually install a drive. You can see how it would fit right into that section. And the connector then for that drive is this one right here. So it's still a SATA, but just with a different style of connector. However, we're not actually making use of that in this computer. Instead, it's got underneath, if I just lift back this black plastic here, we've got this drive right here, and it is in a different form factor that is actually quite common these days in laptops and even seeing in desktop computers. And this is called the M.2 form factor. And that's the actual form factor of the drive, and also it's an M.2 connector here. And generally, these are all held in place the same way. They've just got one screw at the back here, and it kind of like there's like a half moon cutout almost, or half circle cutout right here where this copper is. The screw, it doesn't fully go in it, it just holds that in place. And these come in on an angle, almost like a spring-loaded angle. So what I'll do is I'll take this screw out and we can see how to remove it. It's just a standard Phillips screw again, so I'm just going to unscrew this here. And this one comes all the way out, so I'll just be careful to put that screw to the side, and we can lift this out and take a look at it. So you notice now that I have the screw out, it lifts up, and that's how it comes out. So it lifts up a little bit less than a 45-degree angle, and then we just gently give it a wiggle to pull out. And I'll hold it up to the camera so you can take a look at it. So this is what the connector looks like. Again, it's one of those ones where it's only going to go in one way to help us so that we seat it properly. And then if I just hold this up to the camera, we can see it's a solid state drive. Capacity of this is 512 gigabytes. And of course, this is in that M.2 format. And these are becoming very popular in laptops. It's probably the most common format that you're going to see for drives in laptops. Again, for space saving because they're so small. And then also these can be nice. And like I have one in my desktop because with this form factor, you can also use a different format for actually communicating with the drive. And that's called NVMe. And that's generally going to be something you'll see on these M.2 style drives. And that just means we can actually have much higher communication speeds or bandwidth to the drive itself. So I'll just show how we can go back to install this. Again, it's pretty straightforward. Again, this is going to be one of those things, just like the RAM, where we're going to install it on somewhat of an angle, just slightly less than 45 is how it goes in. And then we just wiggle it in place, and I'll set this back down. And then it just kind of fits there, and you'll see if I let go of it, like it is on a spring, so it lifts back up. So I'll just grab the screw here, and we can just screw it back in place. This is another one of those items where you really don't want to super over tighten it because you don't want to put extra strain on it. So just till it feels tight, and we don't need to over tighten it. And what I'll do is I'll just zoom in quickly to show what that screw looks like. Perfect. So there's what that screw looks like. So both of these formats of drives, including either the 2.5-inch or this M.2 format, they're both examples of something that's fairly easy for us to get in and replace or remove without the need of any specialized tools. So that wraps up this lesson of the course. I'll see you over in the next one. Welcome, everyone. In this lesson, we'll take a look at the location of the CMOS battery inside of this laptop and see how it differs a little bit from that of the desktop one we looked at in the last section. Let's hop over to the workbench now. So the last item we'll look at that can actually be removed from the laptop, or that we could actually take a look at replacing or repairing without the need for any specialized tools or really any in-depth specialized knowledge, is the CMOS battery. So in this laptop, the CMOS battery is actually located up here in the top right-hand section, and I'll just zoom in on it here before we talk about it further. So the CMOS battery in a laptop is actually generally the same size and voltage and everything and form factor as that in a desktop. It's just in a slightly different package. So you'll notice this one, it's actually in this black, in this case, shrink wrap. And if we take a look here, you can actually see that there's these wires that come out of it and go into this white connector here that connects to the motherboard itself. And the way that this works is then on the inside of the shrink wrap, there's two connectors here that are actually just either soldered or pressure fit directly to the battery, and then that's how it gets the electricity into it. So if we want to either reset the CMOS or replace this battery, then what we need to do is actually disconnect this clip here. And it can be a little tricky to do this just with your fingers. So this is where these anti-static tweezers come in place. So I'm going to actually make use of them to actually disconnect this. And I'll just zoom in so you can see what that looks like. Perfect. So I've got this one disconnected, and then this battery is actually still kind of like stuck in place, and I don't want to take it off for this one because it's still working. But what we would do is we would just actually take this back, and then we could use some adhesive to stick a new one down if we wanted to. But what we have done here is at least we have reset that CMOS here. So I'm going to use these tweezers actually just to pop it back in place again. Perfect, and I've got it pop back in place. So that just goes over how we could remove the CMOS battery if we wanted to, and also reset the CMOS. So that wraps up this video. I'll see you over in the next one. Welcome everyone. In this video, we're going to take a look at the location of some of the other core components inside of this laptop that we actually aren't going to be looking at how to repair or replace. And the reason for most of those is that because it's really outside of the scope of this course, and also, in my opinion, for a help desk at a business to reliably be able to repair or replace. So with that being said, of course, you're going to have some standard operating procedures, most likely where you're working as to what you can repair or replace. And one of the things that's probably going to dictate that is actually going to be the manual for the computer. And when you take a look at that, it's probably going to outline realistically what the customer can replace or what you should have it sent back to a repair shop or to the manufacturer for repair. So with that being said, let's hop back over to the laptop and I'll point out some of those components just so you can see the location of them and what they look like. In the preceding lessons in this course, we've chatted about how to take out a few of the core components. And these are the components that are, just in my opinion, the ones that I think are reasonable for an end user or someone working at a help desk to be able to take out, replace, or reinstall a new one without the use of really special tools and specific training or knowledge in laptop repair. And what we'll do in this lesson is I do just want to go over a few of the other components of the laptop just so it makes sense, where they are. And the first one we'll talk about is actually the CPU and its heatsink and fan. So the CPU for this computer is actually down under here. And we actually have like a similar style here where we have 4 bolts that hold down the heatsink that goes to the fan. And so here's the heatsink right here. And it actually does have thermal paste under here. So we could take this off. I'm not going to show it in this video because I kind of think it's outside of the scope of this course, but you could take this off and reapply the thermal paste. And this tube here brings the hot air out to the fan, and this is the fan that then blows out from the back of the computer. So one of the things we actually could do though is, this fan is pretty clean, but if we were seeing that it was getting pretty dirty and blocking the airflow, then we may want to actually take a look at the fan and cleaning that out. So the next part I'll call out here actually, which is something you could probably replace or repair yourself, is we've got the wireless card. So right here is the wireless card. And then you'll see, of course, all this stuff is connecting into, this back plane of the computer, which of course is the motherboard. So this is the motherboard, all this blue PCB here. And you can see we've got some ports that are actually on the back of it, which are those similar ports that we had on the desktop computer. So if I just flip it over here, we can just really quickly go over. We've got a USB, we've got a HDMI here, RJ45. This is where the power comes in. And then if we take a look at the side, we've got another USB, that display port. We've got an SD reader here. And then if we take a look at the other side here, we've actually got a VGA, headphones, another SD card here. And then this is something that you'll see on some laptops here, just to show, so you're familiar with this. This is actually where we could put a lock into this laptop if we wanted to be able to, have an anti-theft lock. So setting this down, there is one last thing that I want to show here on this laptop, and that is how we actually get power to it. So you'll notice on the inside of this laptop, we actually don't have a power supply, and that is because they take up quite a bit of space. And so generally for laptops, you will actually have the power supply be exterior to it as part of the cable. So you probably, handled these many times in your lives where you have a laptop power supply, and it's got this big almost brick or something in it. And so this is where the power supply actually is for the laptop. So one great resource for laptops is, of course, the actual manual for them. And especially for these business laptops, they're generally going to, give you an idea of what components are realistic to be replaced or what you should send back to the manufacturer. So if you're ever in doubt, then I would definitely suggest, visit Google and also check out the manual for the laptop as well. So that wraps up this lesson. I'll see you over in the next one. Welcome everyone. This video is just going to be a really quick wrap up for this section of the course. So we talked about laptops, which are of course becoming much more popular in the business world, and many more businesses are actually supplying their employees with laptops instead of desktops, of course, because of their mobility, the popularity of hybrid work, or even just hoteling desks where employees need to be able to even just move around the office with their laptop. That being said, it's much more likely that you're going to be encountering laptops in your day-to-day work as an IT professional. So we talked about some of the challenges with laptops being that they're much smaller, and of course some of the components inside of them is not really feasible for us to repair or replace as technicians. Of course, it's really going to be up to the company that we work for to determine what we are going to be comfortable replacing or what they'll have us repair or replace on site or we send away. In this section of the course, we took a look at how we could actually take out the RAM and install more RAM, how we could remove both of the batteries, including the CMOS battery, and reinstall it in the actual battery that provides power for the laptop. And we also took a look at where the drives go in the laptop, how we can remove and install them, and the different form factors that you'll sometimes see for drives inside of a laptop. We also took a look at some of those other components that aren't realistic for us to repair or replace, just to identify them. That wraps up this section of the course. I'll see you over in the next one.
Welcome everyone. In this section of the course, we're going to be learning about operating systems. Of course, you probably have heard of some of the main operating systems out there, like Windows, Mac OS, or even Linux. However, in this section of the course, we're actually going to be learning about operating systems in general and learning about some key points and characteristics of operating systems. We'll start with a 101 style on operating systems, where we learn about concepts like the kernel, userland, drivers, abstraction, and arbitration. We'll then have a lesson where we learn about file systems and how files are actually stored on our operating system. And then we will have a lesson learning about file types and how operating systems actually interact with various file types and extensions. We'll then, of course, have a quick outro video and a quick check-in quiz. That wraps up this quick intro. I'll see you over in the first video. Welcome everyone. In this video, we're going to be learning about operating systems. We'll talk about their general purpose and some of the things that they do, and also some of the problems with computing that they helped us overcome. In the last two sections of this course, we've actually been learning about computer hardware. And of course, if we want this computer hardware to do something, then we need to write some code and have an application that runs on this hardware to allow us to interact with us. If we go back to the early days of modern computing, so we're talking like 70 to 80 years ago, then generally computers would actually be created almost as a one-off, and these would be giant computers that may take up an entire room, and they would generally only be in things like research labs or universities. And when computer scientists or researchers would want to write code or applications for these computers, they would write the code specifically for that computer and hardware. Nowadays, this is called bare metal, where we're just loading our application or what we want to run directly onto the hardware itself. So as the field of computer science grew and more computers were built, this approach of just loading the applications directly onto the computer, it posed many problems. The very first one being, if we had an application that was specific to one piece of hardware, and then we wanted to, move that application and have it run on a different computer or many computers, this would usually require a lot of work to rewrite the code that was specific to one piece of hardware to actually work on the other piece of hardware. And then the developer of that application would actually have to have very in-depth and intricate knowledge of how that hardware actually functions, since their application was communicating or interfacing directly with that hardware. In addition, a lot of times we would want to queue up applications so that one would run after another, and this involves someone actually having to go and manually unload the one application and then load another one in. Also, sometimes there would be times where the computing resources of the computer wouldn't be used while it was waiting for some external hardware, maybe like a printer or something like that, and we would want to use the computing resources for another application. However, that wasn't possible because we would actually have to unload the one application and reload the other one. So these are some of the first problems that necessitated the early operating systems to be created, and they're actually still some of the main reasons why we use operating systems today. So to learn more about that, let's actually hop over to the whiteboard now. So I've broken down a modern computer into the three main components that allow us to actually interact with it and have it do useful things. So at the very bottom here, we've got the hardware, and this would be things like the CPU, the RAM, of course, maybe the disk, but it would also be any I/O devices. So that would be things like, for example, a keyboard. So we got a keyboard here, a mouse, maybe even like a webcam or a microphone. So all of that would make up the hardware. And then in a modern computing system, of course, we have the operating system installed on top of that. And nowadays, some modern operating systems that are on our personal computers are Windows. We've got Linux. Of course, we've got all of the Mac OS. And then this isn't just actually limited to what we think of like personal computers. Of course, in phones, we have things like Android or the iOS operating system. And also, this isn't just limited to phones or tablets, even, microcomputers or IoT devices or some of the computers that are in our cars. A lot of these are also running operating systems as well, just because of the advantages that operating systems give. Of course, then on top of the operating systems, we install all of the applications and utilities and libraries. So these are all the things that actually let us do something on our computer. So this could be things like, for example, a web browser, if we want to browse the internet. Maybe something like a video game, if we want to play video games. Or some sort of office application, so word processor or Excel. So of course, when we want to launch up an application, if we even just think of the web browser, for example, well, this is going to need to use some of the resources of the hardware. Of course, it's going to need the CPU and it's going to need some RAM, and the application itself is most likely stored on the disk somewhere. And in a modern day system where let's just take Chrome web browser, for example, is installed on an operating system, well, it doesn't actually have to worry about what CPU we're using or what kind of RAM. It doesn't need to know about our keyboard or mouse or anything like that. It's because it is installed onto the operating system, and when it wants to interact with the hardware, it actually does so through the operating system, and the operating system then actually interacts with the hardware. So you may remember this term we were actually learning about in a previous section. It's called abstraction. This is one of the very core or important things that operating systems do, is they actually abstract the hardware away from the applications that the users interact with. All the designer of an application needs to know about is designing that application for a specific operating system. So if they were going to be, designing Chrome for Windows, then they would just have to make sure that it functioned on the version of Windows that they want. And then a user can go and take that to any different laptops or hardware configurations using different keyboards and mice. And it doesn't matter to the application because it will just talk to the operating system and have the operating system interact with the hardware on its behalf. So to do that, the operating system is generally kind of thought of in two distinct pieces or separations. And I'll actually just kind of split this here to think about that. And sometimes it'll actually be talked about as the top half and the bottom half. And at the top, we have what's called userland. So this is where the applications actually run. So things that we install on the operating system, they run in what's called userland. So the bottom half here then is what's called the kernel. And the kernel of the operating system is actually what's responsible for interacting with the hardware. So when an application that's running in userland actually wants to access some of the hardware, it of course needs to do so through the operating system, and more specifically through the kernel. And the way that it actually kind of bridges this gap between userland and the kernel is through what are called API calls. API stands for Application Programming Interface. And essentially what this is in an operating system is it's a set and agreed upon list of functions or commands that we can call to the operating system and then have it perform some interaction with the hardware for us. So then the kernel actually goes and interacts with the hardware. And this is what allows us to have that layer of abstraction between the applications at the top in user land and the hardware that's running below the kernel, because every operating system, of course, has this agreed upon set of instructions that the application can interact with, and then it doesn't even need to know what the CPU is or what the RAM is or keyboard or mouse. The operating system actually just takes care of that for us. So there's another key thing that the operating system does for us, and that's called arbitration. And we'll just talk briefly about what that means. So to give an example, something that I sometimes like to do is I'll spin up my web browser and I'll be browsing Reddit, and then maybe I'll also have my Office application open and I'll be, working along, but I'll also have my web browser open and I want to actually, glance over at that. And so I've actually got two separate pieces of applications running. And, realistically on our computers, there's probably dozens to maybe even 100 different applications or processes that are running in user land at any set time. And each of these applications does not actually have to worry about the other application, doing things like overwriting its memory or accessing disk space that it's allocated or having to share the CPU resources. This is something actually that the operating system takes care of, and it's called arbitration, in allowing us to run these multiple processes at the same time and just take care of sharing the resources on their behalf. So there's a lot of other things that operating systems take care of, and this is of course a very complex topic, and you could probably take an entire university course on this or even go further in the design of operating systems and how they function. My intention for this lesson is just to give an idea of some of the purposes they fill, and if there's one main takeaway, it's just how the operating systems allow us to load applications on top of them and make those applications more portable between pieces of hardware. And they also prevent us from having to have the applications communicate directly with the hardware. That wraps up this lesson. I'll see you over in the next one where we talk about file systems. Welcome everyone. In this video, we're going to be learning about file systems. File systems are a really integral functionality of operating systems because they're what allow us to actually easily interact with and lay out and manage persistent storage and allow us to actually, store files on that persistent storage and be able to easily recall those files when we need to use them. Let's hop over to the whiteboard now to learn a little bit more about their purpose. So first, let's actually just talk about the persistent storage that file systems live on top of. Of course, it doesn't matter what the medium of this is. It could be something like a hard disk or flash storage, or really even a more primitive format of storage like a punch card, where we punched holes into cardboard to actually then indicate if we wanted a 0 or 1. But essentially, that's what the persistent storage allows, is for us to have a series of storage locations where at the very lowest point, it's just a 0 or a 1. And at a very, very low level, if we want to actually access and write to that storage or read from it, we actually need to know the address or locations of those zeros and ones. So to illustrate this a little bit better, I've actually brought back that pictographic chip representation of some really basic storage that we were using in the previous section. And of course, this storage was, again, just a way for us to sequentially store ones and zeros, and it's organized into address locations, which is what allows us to then access the data that's stored. So for example, we had a byte that was able to be stored here. That was 8 bits of data, and it was stored at this A0 address. And then these address locations went down sequentially, and that's how we could access data. So in our example, we just needed to get 1 byte of data, but now on modern computers, of course, we want to get many, many, many bytes, up to kilobytes or even gigabytes of data. So if you can think of if we had a file, for example, and maybe we wanted to write to it, and it was going to take up something like multiple bytes of data. Well, if we wanted to go and access this file or this blob of data here, whatever is in it, well, of course, we're going to have to just keep track of that starting address and remember where it's stored, actually physically on the disk. And then we'll actually need to either know how long the size of it is. So if we just go size here, or at least the end address. And so you can see how this would really start to become a pain or not even feasible in modern operating systems if every time we wanted to save a file, our applications or even the users would have to remember the specific addresses of that file. And also we wouldn't have any way to name it or organize it. And so this is actually where modern file systems come into play, and they allow us to abstract away the actual layout of the physical drive, and we don't need to know about the different address locations. Instead, we can just create an organization structure and give files names. And then the file system will actually take care of all of the behind the scenes stuff, like what physical addresses our specific data is stored at. So to learn a little bit more about file systems and their properties, let's actually hop over to a Windows computer right now. So on Windows, there's actually a tool that's built in to actually navigate and explore file systems. It's called the File Explorer. So if we just open that up, you can take a look at the file system that's on this computer. So file systems are actually going to be what's called formatted onto a disk, and that disk is that persistent storage. And essentially the formatting is putting the disk into the format that's needed for that file system. So on this computer, we just have one disk here. And if I just right click on it, it says local disk C. We can take a look at some of the properties for it. So we can actually see the file system that this disk is formatted as, and this is NTFS. We're not going to go into the specifics of the different file systems, but you should know there are a few different types of file systems that are used in modern computers. NTFS is one of them, FAT32 is another one, ext3 and ext4 are some other examples. And essentially this is just how the disk is laid out and agreed upon with the operating system to be able to interact with it. But essentially they're all going to perform the same basic tasks that we're going to talk about. So if we actually just cancel out of this and take a look, if we navigate to this local disk C in the File Explorer, we can see all of these folders that are set for this disk. And if I take a look up here, actually, we can see what's called the path, and this is the navigation of where we are in the file system. So generally at the very top of any file system is what's called the root. So in Windows, the way that we denote these roots is with the actual drive name. So this is the C. And then in other operating systems, you may just see a slash being used to indicate you're at the root. But essentially that means that we're at the top of the file system and we cannot go any higher above. Of course, we can create folders that help us navigate through the file system. And you'll also sometimes hear these referred to as directories. So if we take a look at the root of the C drive, you'll see that we actually have some folders here. And the folders essentially work in somewhat of a tree diagram in that if we go into one folder, so for example, the users one, well, now we can branch off into many more folders, and even further so if we go into, for example, the Andrew folder here, well, we can branch off into more locations. And if we actually go into the documents folder, then we can finally get to the file that we're looking for. So we just take a look up here again. This is that path to this file. Of course, we start in the root directory, and then we can see all of the folders or directories that we have to go into to get to this file. And essentially, folders are just an organization tool that we can use to help keep our computer organized. In addition to abstracting away the need to know the physical layout of the drive and those storage addresses, and instead allowing us to access files by using human readable names and organize them into folders, file systems also perform arbitration. So one of the things that they allow us to do is have security over who can access the various files. So what users can actually have access to it. So if we actually go, for example, to one of these folders, maybe if we go into users and then take a look at the Andrew, and we take a look at the properties, we also have a security tab, and we can set access to who's allowed to access this folder. So that's a form of arbitration again. And we can also set limits to what applications can access these folders and also how much storage they're allowed to use, each application or user. File systems also allow us to keep metadata about files that can be useful. So if I right click here and then we just take a look at the properties, we can see some details about these files, like for example, its size, its location, the contents of it, how many files and folders, and when it was created. So these can also be useful for administering the files and folders on the computer. That wraps up this lesson here on file systems. I'll see you over in the next video. Welcome everyone. In this video, we're going to learn about file types, or file extensions as you'll sometimes hear them called. This is going to be a quick video that builds off of our previous discussion in the last video about file systems. Let's hop back over to that Windows computer to learn a bit more. So I'm back here in the File Explorer, and I've actually navigated through the file system to this test.txt file. And the whole purpose of actually having the file system is so that we can store and access and write to and read files. And again, if you think back to the very basics of the persistent storage and what a file actually is, well, it's actually really just essentially a blob of ones and zeros on that persistent storage. And the file system helps us to be able to name that blob and be able to recall that data without actually having to know the physical address of those ones and zeros on our persistent storage. So file extensions or file types allow us to go one step further and actually characterize what those ones or zeros or that blob of data in the file is. It's essentially a way of us to tell the operating system and also applications that access that file what it expects to see in those. So all of the file types, and there's thousands of them, they're generally a 3-letter word or acronym. Like for example, txt, we have .txt. Sometimes nowadays you'll even see 4 or 5-letter file extensions. Essentially what these are is they're just an agreed upon format that the data is going to be stored on. So for example, in a .txt file, we have an agreed upon format of where the text would be. Maybe in something like a PDF, we know that a certain amount of data is going to be for the formatting, and then a certain area of the data in that file is going to be for the text or pictures, and so on. So in Windows, there's a few ways to actually denote the file type. One of the main ones is actually just with the file extension. So you can see in the name here, it actually ends with the file type. So we can see right away it is a .txt. If we hover over it, we see it's a typed text document. Actually right click on it and go into the properties here. Of course, we can see the type of file is this text. And also another thing that operating systems will allow us to do with files is to just set what program is actually going to by default interact with that file if we click to open it. So in Windows for text files, it's Notepad. You actually can create files that don't have a file extension. Of course, it's not required by the operating system to have those. At a minimum, it just needs a name. However, the file extension is what helps the operating system know what to do with that file. So if we don't have an extension, it's generally not going to know what to do with that file. There are some other ways that indicate actually what type of file it is, and this has to do with how the first set of bytes are actually stored in the file. So we already talked about this a little bit, but essentially there is usually a byte called the magic byte or magic bits that are at the start of a file that also tell what is the contents of that file and what the file type is. That wraps up this really quick discussion on file extensions or file types. I'll see you over in the next video. Welcome everyone. This lesson is just a outro or wrap up for this section of the course on operating systems. We learned about the 101 on operating system and some of the core functions that operating systems perform, including the abstraction that they allow for between the applications running in user land and the hardware through the kernel of the operating system. We also learned about the concept of arbitration and how this allows us to actually divide up the resources on the computer to different applications and not have to have applications worrying about other ones taking their resources or crashing them. We then learned about the importance of file systems and how we can use them to abstract away the need to know about the physical layout of disks and how they can be used to organize files in folders and subfolders on our computer. We then wrapped up with a quick discussion on file types or file extensions. Hope you enjoyed this section of the course. I'll see you over in the next one. Welcome everyone. In this section of the course, we're going to be learning about virtualization. In future sections of the course, we're going to be relying on virtualization to help us study, experiment, and learn about different operating systems without the need for an additional computer or extra hardware. It's also going to allow us to play around and experiment with these operating systems and install different software on them without us having to worry about breaking or messing something up on our main computer. In addition to needing to understand virtualization for our own practice and studies, it is also a critical piece of technology that is heavily relied on by modern IT departments and businesses, whether that be internally or also to use virtualization to move resources off premises and into cloud virtualization platforms. We'll start this section of the course by learning how virtualization works, what a hypervisor is, and what some of the core benefits of virtualization are. We'll also discuss the different types of hypervisors and some of the different brands and software products that are available on the marketplace and commonly used for virtualization. We'll then discuss what a container is and how it differentiates from a virtual machine. And finally, we'll wrap up by installing our own hypervisor VirtualBox on our computers so that we can make use of it in future lessons to install virtual machines. That wraps up this quick introduction video. I'll see you over in the next one where we start to learn more about virtualization. Welcome everyone. In this lesson of the course, we're going to be learning about virtualization, what a virtual machine is, and also what a hypervisor is. Let's dig right in. Virtualization is the process of creating a software-based version of something that would typically require its own hardware. We can virtualize many things, like for example, network equipment or even storage mediums. However, in this lesson, we're going to be mainly focusing on virtualizing an entire computer, which are often referred to as virtual machines. A virtual machine, commonly referred to as a VM, is a software-based virtualization of an entire computer, including its operating system and any applications we'd like to install on it. Personally, I prefer to use Windows as my base OS. However, when I'm doing programming or coding or software development, I prefer to do it in Linux. To avoid needing to have two different pieces of hardware or two computers, I make use of a virtual machine so that I can have another computer almost essentially running inside of my Windows computer. So let's take a look at what that looks like here. I'll launch up my virtualization software. You can see when I open this up, it opens up just like any other application, but inside of it, I have a Linux distribution called Ubuntu running that is essentially running like its own separate computer. So if I want to, for example, I can open up applications like the browser or the terminal inside of this computer. And then if I want to return back to working in my Windows OS, I can just minimize this like I would any other piece of software, and I'm back to my Windows OS. If I want to, I can even run multiple virtual machines from my computer so long as I have the resources to handle it. Let's hop over to the whiteboard to take a look at how this all works. So when talking about virtual machines, of course, we do still need some underlying hardware and an underlying computer that is going to host or run those virtual machines. And that computer is generally referred to as the host. So I've got this picture of a server here just to represent that. And then what I'm going to do is I'm going to bring up this square here. And this is just going to represent the various different things that are either installed or pieces of hardware that are on that host computer in order for virtualization to work. So of course, one of the main or core components of the host computer is its actual underlying hardware that the virtual machines are going to rely on to be able to run. So we're talking about things like its CPU or processor, of course, its RAM, its storage, so its internal disk space, the various drives it has, and maybe its networking capability. So those are just a few of the core underlying pieces of hardware that the virtual machines are going to rely on in order to function. So in order for virtualization to take place, we do need a piece of software installed on the host computer that's able to split up and allocate those hardware resources to the virtual machines. And that piece of software is referred to as a hypervisor. So I'll write that here. So the hypervisor's responsibility is to actually then partition up and allocate out the resources of the host OS to the virtual machines. Now there's two main types of hypervisors, and that's the reason that I've kind of written this one up here in the middle. So we'll just kind of separate it like this. And the first type of hypervisor that we're going to talk about is called a type 2 hypervisor. Type 2. A type 2 hypervisor is actually installed on top of another base OS. So I'm going to put base OS here. And this could be something like Windows, Linux, or even Mac OS. And the reason I'm starting with the type 2 hypervisor instead of the type 1 is that's what we actually just looked at. So in my example where on my personal computer, I'm running a hypervisor that acts kind of like an application that's installed on top of Windows. And then inside of that application, I can then interact with the virtual machines. Well, that is an example of a type 2 hypervisor. So generally, you're going to see type 2 hypervisors be used for personal use, or also just as the end user would use it. So what do I mean by that? It's generally not going to be something that is managed. It's going to be more something where the actual end user who wants to spin up a VM would do that on their own personal computer, or for like individuals outside of a business, like we're going to be using in this course to experiment with the OS. So one of the downsides to type 2 hypervisors is that they are less efficient. So I'll write that here just so we can keep a note of it. Less efficient. And the reason for that is because we've got this base OS that we still have to install on the system. So for example, if we just wanted to be hosting virtual machines and that's all it was going to be used for, well, we don't want to be wasting resources on running a base OS because they actually can be quite resource hungry and take up some of that underlying hardware that we have. Like for example, some of the CPU, RAM are the main ones that would make it less efficient. In addition, of course, we also have that extra layer of abstraction where when we want to interact with all these VMs, so we can say we could be running multiple VMs up on top here. For example, maybe let's just say we have 3 running here, for example, right now. Well, as a user, when we're interacting with these VMs, of course, we have an extra layer of abstraction between the VM and the hardware, and that it has to go through the hypervisor, then down through that base OS until it is able to access those hardware resources. The 2 most common type 2 hypervisors are VMware. So VMware is the maker of it, and then they call their product Workstation. And that's VMware's type 2 hypervisor offering. And then the other one is made by Oracle, and it is called VirtualBox. So VMware Workstation is the one that I was just using in the previous example, and Oracle VirtualBox is going to be what we'll use for the rest of the course for our virtualization. So of course, there's not only type 2 hypervisors, there's also a type 1. So I'm just going to clear this away so we can talk about type 1 hypervisors and what the difference is. So with a type 1 hypervisor, right, type 1 here, the hypervisor is actually installed directly onto what we refer to as the bare metal. So there is no underlying operating system that the hypervisor is installed on, or that's between it and the hardware. It's actually installed almost kind of like its own operating system directly onto the host computer. So you will commonly hear of this type of hypervisor, a type 1, be referred to as a bare metal hypervisor. And one of the big advantages of a type 1 hypervisor is that it is much more efficient. So we kind of talked about some of the reasons for that when we were talking about type 2, but of course, with it being installed directly on top of the hardware, then all of the underlying virtual machines, so if we just add a few of them here, of course, there isn't that extra layer of abstraction between it and the hardware, and we're also not wasting any resources to run a base OS. Type 1 hypervisors are more commonly used inside of an enterprise or business or commercial environment. And the reason for that is they would like to be able to stand up multiple or a cluster of virtual machines on a server, and that server's dedicated purpose is just to host those virtual machines that multiple people can interact with and can be spun up or spun down or deleted as needed. Now, keep in mind, interacting with a virtual machine, it may not be something like actually remotely controlling the whole operating system. It also could be interacting with something like a web server or a mail server or something like that that has been virtualized. So there are a few common type 1 hypervisors that you'll come across. The very first one is VMware. So VMware, again, that's the manufacturer name. And their product is called ESXi. The second one is Microsoft's operating. So Microsoft has its own type 1 hypervisor. And that one is called Hyper-V. And then the other one that's gaining a lot of popularity right now is called Proxmox. So in this video, we learned about some of the core concepts of virtualization, and we did discuss about some of the reasons why we use it. However, what I'm going to do is I'm going to end this video here, and we'll pick up in the next lesson where we learn about some of the key advantages of virtualization and why it is such a core piece of technology in modern IT departments and businesses. I'll see you over in the next video. Welcome everyone. In the last lesson, we learned about virtualization and what a virtual machine and hypervisor actually are. In doing so, we actually inadvertently discussed some of the advantages of using a virtual machine. However, in this lesson, we're actually going to dig deeper and learn more about some of the main advantages and scenarios when using a virtual machine is beneficial. Before we dive into that though, I'd encourage you to actually pause the video here and just stop to think about what you think some of the main advantages of virtualization and using a virtual machine are. And even better if you actually go ahead and write those down. So pause the video right now and I'll wait here and see you back when you're done. Okay, awesome. Hopefully you came up with a few, and I bet you some of the ones that you came up with are going to be the ones that we're going to discuss in this lesson. The first advantage that we're going to talk about is the ease and speed that we're able to spin up new resources, such as computers that require new operating systems or just resources to run additional applications, and also the ease and speed that we can tear those down when we're done using them. You'll sometimes hear this referred to as agility. Let's start with a personal use scenario. For example, let's say you've heard of a new Linux distribution called Arch Linux that you would like to try out. Without virtualization, you would need to have a computer that you're able to actually install the virtual machine on, and if you don't, you're going to have to buy one or order it. However, with virtualization, you could stand up a virtual machine to test out that operating system in a matter of minutes, and if you find out that you don't like Arch Linux, you could of course easily spin down that resource so you're not using any of those compute resources or just entirely delete it. Let's round this out with a business or commercial example. Let's say, for example, you work on the IT team at a company that has a software development team, and the software development team is rolling out a new piece of software, and they would like to test and make sure that that software is able to work properly on a whole different variety of operating systems. So maybe, for example, Windows 10, Windows 11, maybe even Windows Server, a few common distributions of Linux, and maybe some of the common versions of Mac OS. Of course, without virtualization, we would need possibly dozens to maybe even hundreds of different pieces of hardware to run all of these different operating systems. However, this becomes a much more simple task when we use virtualization, as of course we can spin up all the different VMs with the different pieces of operating system, potentially on just one virtualization server. The second big advantage can be cost savings. So let's hop over to the whiteboard to take a look at an example. So for this example, we'll be using a very basic corporate environment. So let's just say we are Evil Corp. And we can imagine ourselves being on the IT team, and at the Evil Corp HQ, the IT team is responsible for managing 3 servers. So we'll talk about why we need 3 servers, but let's just say we installed 3 identical servers. So we bought the exact same hardware for them. And we're responsible, of course, we had to buy those, so that came out of our budget. And then also we're responsible for maintaining each of these servers. And the reason we need 3 is the first one is going to be an email server. So it's going to run email, and it's running Microsoft Exchange, which is a common Microsoft product for running a on-premise email server. And of course, it needs to be running Windows Server to be able to install this. So we need Windows as our base operating system. Our second server, it's actually hosting a web server. So maybe it's hosting our website or something. And in order for that to run, this is something that's very common, it requires a Linux operating system. So of course, we can't have just one server that handles these. We need a Windows and a Linux. And then let's also just throw on top of there something that will commonly host is a database server. And we'll say that it needs to be on top of a Unix operating system. So it's another operating system that is comparable to Linux, but of course it's actually a different OS. So we weren't able to combine all 3 of these onto 1 or 2 pieces of hardware. We actually need 3. Now let's say we bought these identical servers and we got like a medium run of the line, but actually, like, maybe we'll say this one is at 50% utilization of its compute resources. Maybe the web server doesn't even take that much. This one's at 25% or something like that. And this one's only at 10%. So we have a lot of wasted compute resources, and also so we had to pay for all of these three up front, and of course now we're paying to maintain three of them. So what we could do, of course, to save the cost is instead we could combine all 1, 2, and 3 on a single server that's running a hypervisor. And this can give us great cost-effective savings because now we are just responsible for buying the one piece of hardware and maintaining only one piece of hardware. Of course, in this example, we've only got 3 virtual machines, but you can see how this can greatly scale as we're able to add more and more virtual machines onto a single hypervisor. The other cost saving that ties into the agility is, of course, with virtual machines, it's a lot easier to spin them up or spin them down as they are needed. So if we no longer need them, we can spin them down and use those resources for something else. And then if we need it again, of course, it's very easy to re-provision. Whereas with hardware, it would be a lot more difficult to actually free up that hardware to be used for something and then put it back to what it was originally being used for. The third advantage that I'm going to talk about is the ease of backing up virtual machines and how that can be very beneficial in disaster recovery. Of course, since virtual machines are just software based and there's no hardware tied to that, it's actually very easy for us to just back up and make a copy of the virtual machine. And not only can we do just backups, we can create what are called snapshots, which allow us to revert back to various states of the virtual machine at different times. So one example or scenario where this could be very beneficial is, let's just say we have a very mission critical server that we're relying on and it's virtualized. And of course we have a backup of that server. However, we need to run some important updates on that server as the IT team, and we're concerned about what these updates might do and if they might impact some of the critical software on it. So what we can do is we can create a snapshot of a known working point before doing the updates, and then run the updates. And if the updates do cause any issues, then we can almost immediately revert back to or fall back to that known snapshot that was working. Of course, this can also be really beneficial for things like hardware failure, where if we have backups of the virtual machine, it's a lot easier for us to stand up or recreate a virtual machine than it is to re-provision hardware. In addition, it's becoming quite common nowadays for companies to actually move their virtualization off-premise and into cloud resources, so they have no reliance internally or very limited reliance internally on actual hardware servers that they need to worry about maintaining or replacing. And this allows us to get rid of unexpected costs like hardware failure, and it also makes the failover for things like hardware failure happen behind the scenes from the cloud providers that we don't even need to worry about. So in this lesson, we just discussed some of the main key advantages or scenarios where you may use virtualization. However, of course, there's many more, and you may even have thought of some different ones yourself. That wraps up this lesson here. I'll see you over in the next one where we talk about containers. Welcome everyone. In the last few videos, we've been learning about virtualization, and more specifically, we've been learning about virtual machines and hypervisors. And of course, in the last video, we talked about some of the advantages of virtual machines, with one of the main ones being that we can run multiple operating systems on one piece of hardware. So in my example, of course, on my personal computer, I'm running Windows as my host OS. And then I have a Type 2 hypervisor VMware workstation that is installed. So if we just open that up right now, and then one of the VMs that I'm running on there is the Ubuntu Linux. So just a quick piece of terminology here that we didn't get into. When we're talking about a virtual machine and its operating system, we generally refer to that as the guest operating system. And if we were talking about properties specific to that VM, then we would refer to it as the guest. So in my case, the host operating system is Windows, and then in this VM, the guest OS is Ubuntu. And of course, you'll recall that this virtual machine, it essentially acts just like any other computer. And we can go as far as even if we open up the settings and we take a look at the about of this computer, well, you can see that it actually can tell that it has memory just like any other computer. I've set my hypervisor to allot it about 16 gigs of memory. can actually see that it even picks up the processor. This is the same processor that I have installed in my laptop. And through my hypervisor, I've allotted it to have access to 6 cores of it. We can also even see it has a disk capacity. So it sees that it has a disk here, and I've allotted through the hypervisor 100 gigs. So this VM essentially acts and behaves just like if it were a regular computer installed on hardware. Of course, I could go out and change the settings or properties of it. I can customize it to make it my own. I can install applications as I need them. I can do all of those types of things that you would do on a regular computer. And of course, there's lots of advantages to this. However, if we do go back to the last lesson when we were talking about advantages of virtualization, one of the things that we wanted to do was to be able to virtualize or run a web server. And with a web server, the intended way that people are going to interact with it is through their browsers. If we want to virtualize a web server, it's not very efficient to have a whole underlying operating system and all of the things that come with virtualizing an entire computer. If we want to spin up multiple versions to expand our capacity for that web server, well, it's going to take longer and be more resource intensive. And this is where the next virtualization technology that we're going to talk about in this lesson comes into play, which is called containers. So the topic of containers and how we can create them and administer them, it honestly could be an entire course on its own. So my intention of this video is to just give an idea about where they're used and why we have this technology. The main difference between containers and a virtual machine is a virtual machine is intended to virtualize an entire computer, where a container is intended to virtualize just a single application. And inside of that container, we only contain the things that are needed to actually run that application. So this would be things like the actual code for the application, or its binary or executable, and any underlying things like libraries or frameworks or dependencies that are required to be installed for that application to run. So to give you an idea of what that looks like, I'm going to hop back over actually to my Ubuntu virtual machine, and we will launch up a container. We'll do some nested virtualization where we're actually running a container inside of a virtual machine. So I'm going to pull up my terminal here, and before we actually spin up a container, I just want to tell you about the reason why I created this container. In one of my other courses that I'm working on, I am teaching about assembly, and I wanted to have an emulator of an old school processor to teach about how assembly works. So not all too different from the one we were talking about in section 3 of this course. And I actually found a really cool open source web app that is an emulator. And in the back end of that emulator, it's all coded in Rust, which needs to be compiled. And then the front end is using NPM and some JavaScript. The reason that I bring it up, though, is that in order to actually stand up a local version of this web server and get it running, it required installing a bunch of dependencies and running a bunch of commands to compile the code. And it actually took me about an hour just to get it running locally for myself. And I wanted my students to be able to avoid that. So what I did is I actually then created an image, which is something that we can then build a container from. And the image you can almost think of as like the blueprints to launch up the container. And inside of that image, all of the dependencies are already installed, all of the compilation is already taking place, and it can just start up and host that web server. So I'm going to use Docker to spin up this container. It's the most popular container software out there and the one you're most likely to come across. However, there are other pieces of software that can do containers, including even hypervisors. So to spin up this container, it's as easy as actually just one line of command. So we're going to use docker compose up. And if you don't know what any of this that's okay. But we can see here it's actually already starting to spin up this container, and it's giving us some details back from the container, including that it's up and running, and it gives us the IP address that it's running at. So what we can do now is I can actually just open up the browser here. And I was already navigating to it, so we can just go to that IP address, and we can see now we've got this web application that I can interact with. So as a user, I can now go and try this compiler online and play around with it. So as a user, if I wanted to spin this up, all I would need to do is just grab that code and those configuration files that I created. And then instead of, an hour worth of work to set up everything in the background, it's literally just one line in the terminal as long as I already have Docker installed. So my intention for this video wasn't to go into the nitty-gritty of how we actually create containers or how we administer them. It was more just to give a general idea about how they work and what they're used for. Containers have gained a lot of popularity recently, and they're only becoming more popular, especially in cloud services and for microservices where we have migrated our services into the cloud. Using containers allows us to be very flexible. We can easily spin up multiple containers to scale as we have more demand for our web applications. And then as that demand decreases, it's very easy to spin or tear down those services so that we're not wasting compute resources. Hopefully this video gave you a general idea of when we use containers and what they are for. If there's one thing to take away and just remember about containers, it's that containers are for virtualizing an application and not an entire computer. That wraps up this video. I'll see you over in the next one where we take a look at installing our first hypervisor, VirtualBox. Welcome everyone. In this video, we're going to look at how we can install our first hypervisor that we're going to be using throughout the rest of the course for when we need to spin up virtual machines. And the hypervisor that we're going to be using is VirtualBox. This is a free hypervisor that was created by Oracle, and it's a type 2 hypervisor. So we're just going to install it on top of our host operating system or our base operating system. I'm going to hop over to my computer and let's get started. So I've just opened up my browser and navigated to virtualbox.org, and then I'm going to go to the download section at the website. And you'll just need to pick the package for the different host OS that you have. So I'm running on Windows, but if you are on Mac OS or a Linux distribution, then you'll need to grab these ones. I'm going to walk through how to do it for Windows in this video, and then down below in the description, I will show any differences for Mac OS or a couple of the popular Linux distributions. So I'll choose Windows hosts here, and I'll just put it on my desktop and save it, and I'll come back when it's done. Okay, so my download is done, so I'll just navigate over to my desktop and I have the installer here. So I'm just going to double click to run it. And then you won't be able to see it on my screen, but I've got a UAC, user account control, asking me for permission. So I'm just going to hit yes. And then we can just walk through the installation. So I'm going to hit next. I'm okay with this location, but if you want to change the location, you can. I'm going to hit next. I'm going to hit yes to this, proceed with the installation. Going to hit yes to install this, and then just finally install. And I'll just let the installation run through here. And once it's done, we can just hit finish to start it up. And now we successfully have installed VirtualBox. So if you're looking at yours, you probably won't see any VMs. This is because I have a couple of VMs actually already installed through VirtualBox on my computer, and it's picking those up. You should have done here. And actually in the next section of the course, we're going to look at how we can install a Windows VM and use some of the features of VirtualBox to administer that virtual machine. I'll finish this video here, and I'll see you over in the next one where we do a wrap up for this section of the course. Welcome everyone. In this section of the course, we learned about virtualization, and we learned about some of the key concepts, topics, and advantages. We didn't get that deep into actually using and administering virtual machines, and that's because throughout the rest of this course, we're actually going to be relying on using virtual machines and other virtualization technology to be able to experiment with other operating systems, install different applications, and even create a miniature lab ourselves. So we will get into the nitty-gritty and the actual hands-on of using and administering virtual machines throughout the other sections of this course. In this section of the course, we did learn about virtual machines and hypervisors. We talked about some of the advantages of virtualization and when we should use virtual machines. We then discussed about what containers are and the difference between them and virtual machines, where a virtual machine is used to virtualize an entire computer, and a container is used instead to virtualize just a specific application. In the final video, we actually looked at how we can install our own hypervisor VirtualBox, and we will use this later on in sections of the course. So that wraps up this section of the course. I'll see you over in the next section where we start to learn about Microsoft Windows. Welcome everyone. In this section of the course, we're going to be learning about the Windows operating system. Windows is definitely by far the most popular and common operating system that's used in business and enterprise environments. So if you're going to be working in IT or even security in any role at all, it's really imperative to have a very strong understanding of Windows, because this is what the majority of end users are actually going to be using on their day-to-day basis, especially in a help desk where we are interacting with the end users. The majority of them are going to be on Windows operating systems, and they'll be facing issues with Windows that we need to understand how to tackle and administer. In this specific section of the course, we'll be taking a look at a local Windows installation and how to use and administer just a single local Windows computer. However, in a further section of the course, we will take a look at setting up an actual Active Directory domain and taking a better look at how Windows is generally administered in an IT or business setting. However, we're going to kick things off just with the basics in a local install. We'll actually start by installing Windows onto a virtual machine so that we have a system to test and play with. We'll then take a look at some Windows basics and navigating the operating system. After that, we'll go a little bit deeper into discussing the difference between local user accounts and domain accounts. And then we'll actually take a look at setting up and administering some local user accounts. Next, we'll take a look at how we can both install and uninstall software on Windows. We'll then chat about how local file permissions work in Windows. After that, we'll learn all about Windows updates and how we can administer Windows updates locally. We'll then take a look at a few core Windows utilities, such as the Event Viewer, the Task Manager, and the Device Manager. We'll then learn about Windows services, and after that we'll learn about the Windows registry. We'll then have a lesson on using the command prompt in Windows, and we will wrap things up by learning about how to schedule tasks in Windows using the Task Scheduler. That wraps up this introduction video. I'll see you over in the first lesson. Welcome everyone. In the next two videos, we're going to be taking a look at how to install and set up a Windows virtual machine. We're going to be making use of this virtual machine throughout the rest of the videos in this section of the course, and we'll even return to it at a later section in the course as well. We'll be using a virtual machine for a few different reasons. One of them being, I think it's good to practice the virtualization and to practice setting these up. The second being that it's actually going to be a lot easier in case we break something just to go ahead and revert it, and we don't have to worry about messing anything up on our host computers. And also, this isn't specific to just virtual machines, but I think it's good to see the installation process for Windows as well. A lot of people watching this video right now may be doing so on a Windows host computer or use Windows as your daily driver, and it may be tempting to just use that for this section of the course. And I really strongly advise against doing that. Of course, there's all the benefits that I listed, and then also just, for their own safety of your machine, so that you can always revert back on a virtual machine if you mess something up, whereas it's not that easy to fix on an actual physical computer. With that being said, let's actually hop over now to where we can download a free evaluation version of Windows, which is what we're going to be making use of for our lab environment and for our virtual machine. So Microsoft provides free downloads of a bunch of their products for evaluation purposes, and that's what we'll be using for both our lab and also the virtual machine in this section of the course. So I'm just over at their evaluation center right now, and I will link this down below. Here's the link right here. And we'll just start actually by going to the Windows section, and we're going to use Windows 11 Enterprise for our machine. So I'll just click there. Perfect. And then we can just download the ISO here. We can get it for free. So this is an evaluation version. That's, exactly essentially what we're doing. It's just evaluating it. Even though we're learning it, we're checking out some of the features of it. And there are a few restrictions with that really would only hold us up if we were going to be putting this into a production environment or trying to license it. But for what we're doing and running it in this virtual machine, those features won't limit us. You are limited, I believe, to 90 days before you start losing access to some of the features, and it actually may start restarting on you if you're not using it after those 90 days. So just something to keep in mind. But generally, it's going to work just great, and I use these in my labs, and they're really good for learning and evaluation. In order to download, you do need to fill in some details here. You can put whatever you want here. You don't necessarily need to specifically give their details. So I'm just going to be A, B here. We'll do a@b.com. You do have to fill something in here for everything. Click download now. And then I'm just going to choose the English United States version. If you do want one for a different language pack, then feel free to get that one. But I'm just going to go with the 64-bit English United States version. I'm going to save mine to my downloads. Feel free to save yours wherever you would like. So this is about a 6 GB download, so I'm just going to let it run. And if you let yours run as well, I will see you over in the next video where we actually take a look at installing this in a virtual machine. So that wraps up this video here. I'll see you over in the next one. Welcome everyone. In this video, we're going to take